One of the main themes is word problems, and you're going to be given equations, and there's going to be a context surrounding it. And so you kind of have to remember that your domain and range that you've been using up until this point is going to change. We're not going to go negative infinity, positive infinity every time. It's going to change depending on the situation, right? So let's start the first one here. The path of a baseball that has been hit can be modeled by the following equation. So it's h of t is negative 4.9 t squared plus 35t plus 4. What do the letters represent? H of t is the height. So there's your first. H of t is height, represents the height in feet. And t is time in seconds. Okay. Now, if you remember from last year, whatever is to the right side, this is my x variable. And whatever is on the left side of the equation represents our y variable. Every time. They're not going to trick you there. So when we used to think of every point on the curve we're about to graph, we used to think of it as x and y. You need to stop thinking of it. I mean, it's still true, but I need you to start thinking of what does x represent? It's time, right? Because time is on the right side of the equation. So everything is now going to be time and height. So every x value represents the time and every y value represents the height at that specific point. So don't forget that. That is important to remember. And so a lot of the questions that we're going to do here, guys, they're going to do this. They're going to either ask you, what is x when y is 5, let's say? What is x when y is 5? If you are encountering this situation, we're going to let y2 equal to 5, and then we're going to go second, trace, intersect. Yikes. It says intersect, I promise. If it says, what if it says x is 2.4, it tells you the time, it's going to ask you for the height. What if you have this scenario? What do we use to figure out y in this case? Anybody remember? Second, trace, value, and then we let x equal to 2.4. Okay, so that's kind of like the theme. This has nothing to do right now with the specific examples. I just made these numbers up. But this is going to be the theme. Like, you might be given the y value. Like, let's say they ask you, how long did it take to get a height of 5 feet above the ground? You know you're in this scenario where it's like, oh, y is 5. I need to find the x value. I need to find the time it took me to get there. Or it will say, how high was the ball after 2.4 seconds? That means you know the x. We need to figure out the height, the y value. Okay, so those are the main questions that you're going to see in this type of in word problem land. Okay, so what is the initial height? What is the initial height of the trajectory of the ball? Okay, so basically at what height was the ball hit? Initial height, this happens at time 0 seconds. That is your initial height, right? So when the time isn't going yet, that's basically when you just make contact and we start the timer. That's our initial height. So basically when x is equal to 0, what is my height? That's what it's asking for. What do we know this point as? 0 something. If we have 0 something, we call that the y-intercept. Okay, so we actually know that it is 4 feet. But let's say you forgot, you missed you're still kind of waking up, right? Second trace value, x is equal to 0. and that's how we would find it. Can I ask you to type this in, because we're going to need to type it in anyways. Kind of went a little bit too fast there. Y equals, clear everything, negative 4.9 x squared plus 35x plus 4. So the variables may be t, m, n. It might be different variables, but we still always type in x for those variables, okay? So we have that. We're expecting this to be pointing down, right? Guys, sometimes I walk around on the exam and there's a question like this and the parabola is pointing up and I'm like, don't you notice, right? So you got to make sure if it's negative, it should be pointing down. And by the way, a baseball doesn't keep going up, does it? I mean, just think of the context. Hit graph. Not bad. I'm going to go zoom standard here, just so we all see the same thing. So if you want to see the same thing I'm seeing, zoom standard. And I do see both of the legs here. I want to see a little bit more at the top. So window, I'm going to change my Y max to, you probably already know, right? Is it 60? I'm going to try Y max 60. Nope. I'm going to try 70. I'm going to go 80. I know it's better to go a little bit higher than the bare minimum. So that is a pretty good graph. I would say that there's no need for time to be negative, right? So I will actually go to window and change the x min to just, -3 or something. I don't want to see too much in the negatives. I'm going to hit graph again. So I'm basically interested in quadrant 1. Most word problems are in quadrant 1. Sometimes, like a roller coaster question, it may be that the roller coaster goes underground for a part of the stretch. So then obviously we would want to see some of the quadrant 4 here, but time has to be positive, and we're only considering the baseball being above ground. So this is where we're interested in, okay? So let's find the initial height here. Second trace value. So the first option, x is equal to 0, y is equal to 4. So you know for sure. You say y is equal to, watch this. I know that you may have been told you need a long sentence and stuff. You don't actually need that. You just need to have units if you want the right answer. So we're now saying that it's 4 feet above ground is the initial height of the ball, okay? Next, determine the maximum height. What is it asking for? The vertex. Yeah, we know that as the vertex in general. Any parabola, right? Changes after that, changes trajectory. So let's go find that. Second, trace max. So let's go ahead and find that. Second trace max. If you select min, you're not going to get the right answer. So somewhere to the left of it, hit enter. Go over to the right. So you got to go left and right arrows here. Hit enter, and then enter one more time to find it. And so I write down both of these numbers. I write down the coordinate, 3.57, 66.5. And some students just leave it like that. But this is not quite right, because I don't know which one is it. Do you know which one it is, right? So we want the maximum height, so it's the 66.5, right? So 66.5 feet above ground. If this had been a negative number, guys, let's say it's a scenario, then we would say below ground, right? If a bird goes underwater or something happens to go underground, if this had been negative, then obviously this would be below the surface, okay? Keep going. How long does it take for the ball to hit the ground? How long does the ball remain airborne? The same thing. So how long, that's time, to hit the ground? How long is the ball airborne? When does that happen? It happens when the height is 0, doesn't it? right? So we're wondering what that time is. So what do we know this point as? If y is 0, x-intercept. So we know the y value, so it's y2 is equal to 0, second trace intersect. So let's go ahead and do that. Anytime you know the y value, put it into your y2, into your second y. Put that number in there, and then graph. So now you know, okay, that's where we're at. That's the height we're interested in. Do not pick the negative value, right? If you think about it, this curve kind of goes into the negatives here. Don't worry about that one. You want this one right here, positive time. So second trace 5. Go closer to that one. That's close enough. Enter, enter, enter. And that's 7.260. Again, that's the coordinate. That's the x-intercept. We're not done yet. We need to answer. It takes 7.26 seconds. So you got to go with the units that they're giving you. That's what you go with. Are we good so far? Does that bring back memories? Good ones? Okay, I'll try to make them better. Calculate the height of the ball 1.5 seconds after being hit. So they're basically saying, hey, if time is 1.5, what is the height? That's what's happening here. So we're going to go second, trace, value, x is equal to 1.5. So this part is, I think, pretty straightforward as long as you remember, how do I make this appear on my screen? This is the hardest part. How do I make this graph appear on my screen? So we're going to go second trace value, and now x is 1.5. That's what we're interested in. And there's my y value. It's 45.48 seconds. No, feet, my bad. So after 1.5 seconds, that's how high the ball is above the ground. I should have left a little bit more room, but I wanted everything on this page. Now, everything was at specific times. This one is a little trickier. Determine the time the ball remains at or above 49 feet. To bring back some good memories, this is kind of saying at least 49 feet. Remember the at least? It has to be 49 or more. Okay? So we're interested in that. So basically, it's a little trickier than just finding what the x value is at 49. So think about it this way. This is our scenario here. Okay? We are given a y value. This is a y value. So let's enter that into our calculator, into y2. y2 is 49, then hit graph. And you will see that it happens 2 times, right? This ball reaches 49 feet 2 times. So we're trying to find out how long was it, did it take from here to here, right? Like how long was it above, at or above 49? So I'm going to grab a red pen here and just draw my 49 line here. This is y is equal to 49. So we're going to find the first time it happens. So let's go ahead and find this. This is T1 here. First time that happens. So second trace intersect. Go closer to that first intersection, hit enter 3 times, and we write down 4 decimal places if you want to get full marks, because we're going to have to subtract them. Okay? So 1.6816, that's the first time that ball reaches that height. The very first time. But it comes back to it. Time 2. Let's figure out time 2. We got to repeat the process. Second trace 5. We get to there, and then it's enter, enter, enter. And we get 5.4613. So it happens again after 5.46 seconds. And now something that I call delta t, like difference of time, is 5.46 something minus 1.68 something. That means the 4 decimals. So we're going to figure out the difference in time. That ends up being 3.78 seconds. This is really tight, eh? The space. I don't know what I was thinking. That right there is the time that went by between time 1 and time 2. So you're basically finding out, right, the time that went by where it was above it, at or above. So it took 3.78 seconds. This is a 2-mark question, guys. If you see a 2-mark question, it's not just go find a point and answer. You would get half for each time and then a full mark for subtracting. Okay, so that's kind of what would be happening there. Let's graph this scenario. We actually have a lot of information to graph this already. Okay, so what you need to do is make sure you label with units your x-axis and your y-axis. So we're going to go time in seconds. That's a must, right? So time and seconds. And then above here, it's going to be height in feet. So time, seconds, height, feet. Get that out of the way. Now, the x-intercept is going to tell me how far along the x-axis I need to account for, which is what? When it hits the ground, right? What is that time, the x-intercept? That was 7.26, remember? So let's see if we can make this work. 2, 4, 6, 8, 10. That works pretty good. If you go up by 1, you would run out of space. So I'm just going to go up by 2. So 2, 4, 6, 8, 10. And in terms of the y, I need to figure out the highest point I ever reach, which we already know. It's 66.5 feet. Okay? So let's try this. 10, 20, 30, 40, 50, 60. It would be a bit too tight. So I'm going to go, we can go 20s. 20, 40, 60, 80. My bad, the 60 is kind of crammed in there. But that will do the trick for me. Let's plot all the intercepts, the vertex, and then we have ourselves a curve. So 7.26, this would be 7 right here. Right, between 6 and 8 is 7. 7.26 is somewhere there. So that's where I make my x-intercept. Does this start at the origin? It does not. It starts at 0, 4. So this will be 10. This is 5. So 4 is right about there. Just make sure it doesn't touch the origin, and then you're fine. And the vertex is at 3.57. So this will be 3. This is 3.5. And I go all the way up to 60. This would be 60. That's 70 right there. I need to be at 66. So that's where I kind of would put my points. Close enough is good enough. It's actually a running joke between applied teach. It is actually, we would never split hair here. Like if you're close enough, it's good enough. If it has to be on an exact number, like if you have 6, 0, we would definitely expect you to have it on 6, right? But if otherwise, don't worry about it too much. I go to my vertex, I go out a little bit, and then I curve down to that starting point. Then I go back to the vertex, I curve out, and I go to the x-intercept. Last but not least, you need to have your equation on there. That would be a full mark question. Now, we're used to arrowheads everywhere. So for example, Mr. Dixon, is it okay if I put an arrowhead on one of these legs? Please don't, because then you're saying this thing keeps going underground if you do it here. And if you do it over here, you're saying that time is negative and it's also going underground. So it would technically be a -1 because you're going against the domain and range. Okay? Fun stuff. State the domain and range of this scenario. Assume that the ball stops upon hitting the ground. So we're assuming that, right? It doesn't, we don't consider it bouncing and rolling on the grass. Like that's not what we're considering here. I might have to review domain and range a bit more, but for the domain, it's the x values that we're considering. And just for this purpose, I'm going to use 2 different colors. For the domain, if you go in the graph, normally I don't want you to do this, but in terms of x, like if you run along the x, you start at 0, you keep going until the ball hits the ground. So we're basically saying for x, right, in this particular story, x has to be between 0, times 0, and time, what is this, 7.26? Right? It is comprised between these 2 points. So I have to say from 0 to 7.26. That's it. That's, what notation is this? This is interval. It's the easiest one in my opinion, okay? Then it's range. Range is a little different. You're looking at your permissible y values. And you have to look at the entire graph. Does this start at 0 when it comes to y? Is 0 included in this story? Yes, because it hits the ground, right? So you're going to go from 0, you keep going, until you get to the vertex, right? That determines the end of the range. And I'm going to give R that green color so it sticks out. So we're going from 0 all the way to, what's the highest? It's 66.5. There we go. If you are a rebel and you like your set notation, you have to use squiggly brackets and you have to go from 0. For x, what's my variable for x in this particular context? It's actually t. So you have to use t. You cannot use x. That's why I don't recommend this one. So you're basically saying x is in between 0 and, t, the variable t is between 0 and 7.26, inclusive, right? You're including the ends here. or it goes from 0, h of t, or just h. It's up to you. But in this case, y is the h variable, 66.5. Okay, so those are your options. I would say go interval. The only time that you need to really know your set notation is if they say, hey, is this the range? Is this the domain? And it might be a multiple choice question, and they may only choose to use set notation. Then I would still expect you to be able to read this and understand what's happening. Okay? We're gonna skip H. I'm not gonna do H just yet. Write another equation that would model the path of a ball with a lower maximum height. What should we change for the maximum height to be lower than what it is right now? Out of the variables, think of it this way. Do you remember which one of these did like a vertical shift up or down? Which one was it? Was it A, B, or C? It was actually this last one right here. Okay? So what we will do is decrease C. Okay? That's what we're going to do. So for example, another equation would be h of t is negative 4.9 t squared plus 35t. And what am I going to do here? I'm going to say plus 3. Anything lower than 4. There used to be a 4 there. We're going to do 3. And if you're not sure, use your calculator to help you out. So for example, I'm going to type this in. And I'm going to go plus 3 here on my second. I'm going to graph them both at the same time. And if I hit graph, it's not quite as visible, but if you zoom in, fail, right? Whack. If you zoom in, you'll see it. See? Slightly lower than the previous one. So there's other ways of doing it. You can change A or B as well, but to me, this one is the easiest one to do it with. Okay. I just want you to try 28 and 29. Okay, so that's your homework. One is a linear, one is a quadratic. Linear are easier. You don't have turning points, right? It's just x and y intercepts.